So last class we discussed about arrays, the operations on arrays. So there first we started with the traversing, then we did searching. There we use two methods. One is linear search, so another is binary search. So now we are learning the algorithm called insertion. That is the operations which can be performed on array, linear array. So when you have an array, so there you can add or insert a new element into an array. So provided the array has a sufficient space to accommodate new element. The insertion, so whenever we perform insertion operation means, so insertion has to be done at a particular position. From that position, so all the elements are moved to the higher order position, they are shifted. So in other words, imagine you have some elements or something you have arranged means when you are inserting somewhere, so either this end or this end has to be moved from that point to the remaining. So maybe you have seen in some queue, so where people are standing in a line and somebody joins in between means, so then all the people has to move to their next position. That is, they have to shift. They have to create vacant space and then new person can be added in that place. Exactly similar, we are trying to insert an element in an array. So when you have a number of elements and this element we have to insert at particular position means from that position till the last element, all the elements are shifted to higher order position. So if you take an example, so we have an array, some elements, we'll take some number of elements, we have 2, 3, 4, 5, something like this. We have a subscript 0, 1, 2, 3, 4. So now what I am trying to do means, I want to insert some element at 4. Suppose I want to insert an element 1 at the position 2, where we have right now the element 4. So what we have to do means, from this position, all the elements are shifted to its higher order position. That is, 5 has to be moved here and then this 4 has to be shifted. So vacant is created. So thus then our element is inserted. So this is how we are going to insert an element into an array. First, from that position, so all the elements, subsequent elements are shifted to their higher order position. Then vacant space is created. So there the new element is inserted. So this is how we perform insertion operation. To perform insertion operation, so I have to start with the last element and then all the elements will be shifted from my lower order position to higher order position. From last element till the given position, all the elements are shifted to higher order position. So this is what the theme of algorithm, this is the main concept. So we'll write an algorithm to illustrate this and we'll take an example once again. So what is algorithm we are trying to write means, it's called insertion. Write down algorithm, insertion. So let A be an array with n elements. So this algorithm insert an element item into an array. That is how we have to do. So let us write an algorithm and then you'll understand. Once again we'll trace with the algorithms. So let me write algorithm as usual. So step 1, start. Step 2, so I have to start from given position till the last element we have to shift. So therefore let me start with for I equals, here I start with the last element because I have to shift from last element to the given positions. Here I am using down to loop. So down to till means P. Do the following step. This is a decrement loop. We had for loop so far, increment loop. So now we are using decrement loop. What we are trying to do means, so A of I plus 1. So I means last element. I plus 1 means next position. So there we copy the present element. So last element is shifted to next position. So there every value of I we are moved to its subsequent next higher order positions. So repeat this for n. So after this we shifted all the elements from last position to till given position, and we have created vacant space after this. So there we had the element, that is A of that position P, I, P and I are same now. So there I add item, this is an element to be inserted. So after insertion is done means the number of elements is increased by 1. So n equals n plus 1. So next stop. Correct. No, so when you add one more elements, the size of an array is increased by 1. So this is algorithm which is going to insert an element into an array. Let us take an example. That is, we will go with the algorithm and see how it works. So let A be an array with some elements. Let me take some number of elements. 1, 2, 3, 4, 5, 6. Let me take some element like 2, 3, 4, 6, 7, something like this. Suppose I want to insert some number at some position. This is an array with n elements. This is subscript, as usually we know. 1, 2, 3, 4, 5. Right now we have 5 elements. So now item to be inserted means, let us take you are trying to insert an item element 1 at some position here. So I have to insert at 1, the position is 2. Indirectly, I have to insert 1 at 2. So we'll follow this algorithm, and this algorithm must, let us follow this. What will happen? So what is n means? Number of elements. How many elements are there? You can see here 1, 2, 3, 4, 5. There are 5 elements. So therefore 5 minus 1 is 4. I'll write n is 5 minus 1 is 4. Now down to p. What is p means? At position 2. We have to insert at 2. Now what is I? 4. 4 is greater than 2. Yes, repeat. Decrement loop works. Initial value should be greater than or equal to final value. Each time the value is decreased by 1. So now compare with the position. Now take the position, the value of I. What is I? Normally we are taking 0, but it is opposite. Down to loop, start with 4. So what is I plus 1? 5. So now we are referring to these positions, 4 and 5. At 4, we have element 7. At 5, we don't have anything. That is, the element 7 is shifted to at A of 5. So we have 7, this is shifted, I plus 1. So this is the only statement has to be repeated. Next time, I is decreased by 1. So this is a down to loop. So minus minus. So it was 4, now it is 3. So 3 is greater than 2. Repeat. Again you repeat. Now again you shift. Now the value we are referring is 3 and 4. I is 3, I plus 1 is 4. So as 4 is vacant, 3 we have an element that A of 3, 6 is shifted, copied to A of 4. That is A of 5, 6, A of 5 plus 1, that is copied. So then what happens? I minus minus. So I becomes 2. 2 is greater than 2 is false. 2 equal to 2, yes. Repeat again. So I have to repeat the positions with I is 2. So now we are referring 2 and 3. I is 2, I plus 1 will be 3. So the element at A of 2 will be shifted to A of I plus 1, which is 3. So the element what we had here is shifted to 4. It was here, it is shifted now. Next what we do, so the vacant is, let us see. I minus minus, so I becomes 1. So 1 is greater than or equal to 2 is false. It is neither greater than or equal to 2. So we stop. That's the end of the for loop. Now we can see the vacant space is created at 2. Now we add an item. So that's what we did. Item to be inserted is 1 at A of P. So what is P means? 2. So at that position we are adding an element 1. That is an item we took. That's a 1 is the element to be inserted. So next n equals n plus 1. So what is n previously? So 5. So n becomes 5 plus 1, 6 now. So you can see 1, 2, 3, 4, 5, 6. There are 6 elements. So this is how the element, that's an element can be inserted in an array when we have a sufficient number of space. Normally we have to check the array has space to accommodate the new element. Now you want to insert another element for this given array. It is not possible because we don't have a space. So if you have more space, you can add one more element. So this is what is called as insertion. So we have to write a program for this. We have practical also, and also we have a theoretical. Practical, we will be using the object-oriented programming. So let me write here also, and then we'll continue in the practical manual as well. So I think you have understood. So write down this algorithm. So it's in the textbook, you write this algorithm. So sometimes they ask the 2 marks or 3 marks this example with algorithm with example, or sometimes they may ask program. But practical programs, definitely we are going to use this. We'll rub this. So next I'll write the program, the same thing, we'll write program. I think whenever we have programs means the problem is divided into 3 steps. Already I have told the programs, we have to divide the problem into 3 subtasks: the input, processing method, and the output. So input will decide. So this let A be an algorithm. So what we are trying to insert an element item into an array. Array you required, the size of array automatically we needed. So subscript we need to process, and then we need subscript, that's normally we have to declare, and one more, the element to be added, that is we take item. So this is enough. If we want anything else, we'll decide later on. So let me start the program. I'll write from here. We can start from void main. So what we needed, so what to declare first, all the variables which we are going to use in the program. So what we are using, an array means one dimension array, so A of 10, this is compulsory for every array programs, and then we need this also compulsory, n subscript. So depending on what process we do, now we are inserting. So insertion means we need what you are trying to insert, an item. So I think these are the sufficient. If you want, we can declare them. Let us supplying the values for this. So this statement will create only that array with nothing. So that's 10 consecutive memory locations or block, and it is given by name A. So now let us supply the value for each elements. This already we are familiar. So enter the n, so number of elements. So n line. Next C in n. Then what we do, this will number of elements, like n we took 5, so similar way. So n equals 5 or n is equal to 6, n is equal to 10, any number you can give. So next, so enter elements of array. So now elements. So elements of array. So it's not only one element, so many elements, so we have to repeat. So if you imagine right now how it looks means, you can write here. If you write this, I'll write here exactly here how it looks. So this is some array 2, 3, 4, 5. Just six I took, no problem. So let me write 0, 1, 2, 3, 4, 5, 6. And this is A, array A. And right now it's empty. So I've given n equals some 5 elements means, so n is 5. I have repeat now. I have to repeat 5 times. So whenever we repeat, so Cin, that's what I'm trying to write here. So this declaration will be like this. So an array A with a blank consecutive memory location. So I input n, so n is equal to 5. That's also named memory location. Right now it contains 5. Next what we do, so we input for I equals, start from 0, I is less than n, I plus plus. So C in input A of I. So A of 0, enter. So suppose if I input some number 2, so the A of 0. Then I plus plus, I becomes 1, so some number 3. Then I plus plus, then I becomes 2, some number 4. Then 5, some number example. Then 6. Then I plus plus, I is less than or equal to 4, becomes false, we quit. So we enter 5 elements. So this will declare memory, and we supply the value for those memory locations. Next is element to be inserted and the position. So there are two things we needed, item and then position. So these two we had to supply. So we are now declared variable here, position, define P, position. So next what we do means, so see if check the position you are entering, let me write here, this is not clear here, let me write position first, C out, so enter position, where you want to insert, enter position, end line, so C in P. So we got the position, maybe any number. So it may be 5, it may be 6, it may be 0, or it may be 100, or it may be minus 10 also. So therefore what we have to do means, before we apply the what we call insertion algorithm, let me check is it the position is valid or not. So therefore first we check if P is greater than N. So P is greater than means, so it's something outside. So therefore what we do, so it's an invalid position, we write C out, invalid position. So position, or you can give any error message as you like, enter proper valid number or anything. So it's just I wrote, it's an invalid position. Else it may be some positive number which is a correct. So it may be between 0 to n minus 1. So therefore, possibly you can insert, at the beginning, end, or somewhere else, whatever the depending on the position we are going to insert. But n is greater than means it's outside. So therefore, first we have to check is n is position is outside an array. So if it's an outside means we cannot insert. Like here it is P is equal to 25. Whereas we have only maximum 6. So we cannot insert at 25. So that is the concept. So therefore, if P should be less than n, so that's what I said. If it has a sufficient space to accommodate new element. So now that's why that is how we indirectly this will be deciding. So after this what we do means, so we enter one more, that is let me use flower bracket, many statement, we have to repeat compound statement. So C out, after confirming, so enter the element to be insert, enter the element, enter an item, whatever you took you can write. Enter the item means item, element means element. In this case I took item, variable name, so I took item. Suppose you input this item 1 means, so the value will be, item contains 1, the value. Then what we do as usual, start from algorithm. We have to follow for I equals, now we have to write n minus 1. I is equal to 0, 0, normally we write, but here we have to start with I equals n minus 1. So here also I is less than n, we are familiar, we have to be careful, greater than or equal to P. Position, so each time decrease, I minus minus. Now what we do means, we follow the procedure, that is A of I plus 1 is empty, higher order, there we copy A of I, exactly similar to algorithm, semicolon. Repeat this for loop. After completion of for loop, so A of P or I, you can write both are same, is equal to item. Insert an item now. So after this, n plus plus you can write. N is increased by 1 or n plus plus. So next you can display the array elements on. To confirm, so write C out array elements, that is array after insertion or arrays, you can check, verify, array elements or, that is to confirm. Can use any message, string message, so array after insertion, so array is successfully inserted, and you can see those things. So then we write again array means it's not one element, we have to start from 0, I is less than n, I plus plus. Then C out, we are displaying, so use a set width, otherwise they will come together. Set width of 2, then you write A of I. And this is the end of else statement, this is the end of program. So else closes, then end of program closes. So now let us follow this procedure till you have understood position is 2, we have input and item is. So this is greater than, position what we enter is 2, 2 is greater than n, false. So n is, actually it is 4, n is number of elements here, 1, 2, 3, 4, 5. So 5, you can see here n is 5, 2 is greater than 5, false. False means else. Repeat these steps. Compound statement. Let me start with enter an element to be inserted. Let me take 1 element to be inserted. See in item. So you got the value. Whatever you type from the keyboard, it may be 1 or any number you can give. So now this is a searching, so it is insertion algorithm. So now n minus 1. What is n? 5. So n minus 1 becomes 4. So 4 is greater than position 2. Repeat now. What you are trying to do means I plus 1. So what is I? 4. You can see here I is 4. I plus 1 will be 5. So now 4 and 5. At 4 we have element 6. At 5 we don't have anything. So this 6 will be copied. So that's what we do. Same thing is repeated till the second element. This already I have explained. So I'll write directly. Then it is 5. I minus minus. Then it is 4. Then I minus minus. So then we quit. So at that position A of 2, we add an element here. You can see here item is equal to copied. So 1 is copied here. Then n plus plus. So n previously 5, now n becomes 6. So then display an array elements for. So display 0 output, the element first is 2, then I plus plus, I becomes 1, space 1, 2, 2 space set width, otherwise it comes together. Then I plus plus, I becomes 2, 2 is less than 6, repeat. So 1, then 4, then 5, then 6. The element 6, I plus plus. So I becomes 6, 6 is less than 6 is false. So we stop and we have seen all the elements are displayed here, 2, 3, 1, 4, 5, 6. This is the new element inserted. So this is how insertion program algorithm, the same thing we have written program. You can copy this from the textbook, it is there in the textbook, and then we'll continue next. Next is a deletion algorithm. I think it's very simple. You see there, you can copy this, you can pause and copy here, or better you use the textbooks. Only thing is try to understand the logics, what I'm going to explain, and you copy from the textbooks, no problem. So, but you prepare the notes, these are all important. But when you do practical, this same technique we'll be doing. So the only thing is, this is we take input here, from year to year, we name one class, that is object, one function, from year to year, another, output, another. So that's how we do. It's very simple. If you know this, and only that programming technique is simple, no problem. It's not going to be very difficult. Okay, this is something about insertion. So next we'll go for deletion algorithm. I think deletion, now you are inserted, let me rub these things and then take the same example how deletion can be performed. We'll take algorithm first, then we'll go for the program as well. So now what happens? Deletion is a process of removing an existing element from an array. So look at the array, we have some elements. So at given position, we have to delete. Like sometimes people are standing in a queue, and normally when you go to movie and you are waiting in a queue, and one of friend you go somewhere else, he got the ticket. Some example. So he was just waiting in the queue call. So immediately you run away. So you leave the space. This practically we have experienced. Then what happens? That vacant is created, all the elements are moved further. So that is, they are shifted to lower order position. There it is higher ordered insertion. Here what happens? When you remove an element, so vacant space is created, automatically elements from higher order positions, they are shifted to lower order position. If you remove, if you look at this, the same thing, suppose I delete 1 here, what happens? The remaining element after 1 will be shifted to lower order position. See, it is at the position is 3. now they are shifted to position 2. So 5 is at 4, now it is shifted to 3. Now 6 is at 5, it is reduced. So this is the deletion after. So this is a very simple one. So all the elements from that position, after first you have to delete the element. So after deleting, the vacant space is created, empty space creates. So the subsequent element after that position, all the elements are shifted to lower order position. That is, their higher order right now, the positions you have to take. So they have to be, so that is indirectly how this shift or movement is made means when you see physically, the organizing is very simple. No, people are standing, you push them, come like this, come like this. Or you can see with the eyes, I did very simple, you can swap this. The same mathematically we do means the subscript, the mathematics becomes very important. That's why the machines works with the mathematics as usually I'll tell, always I'm trying to tell the machines works with the mathematics. This also example, see without mathematics. So all numbers we are swapping, shuffling the positions and elements are shifted. That's the way, that's how machine can also you do. Where we see and there is a vacant space and we shuffle. And same way machine can also do this now, the same technique what our brain does, but it does mathematically using the subscript positions. We use eyes, visuals, the numbers and we interchange them. Similar way, because we cannot see the number, machines cannot see what is there, so they have used mathematical positions. So whenever greater than or something like this, what is depending on the requirements, we change them. So once it is deleted, so all the elements will be shifted. So that's what we repeat. There is no comparison, just copying. From where to where? That is from where? From the position p plus 1. If it is a p means from p plus 1 to the last element, all elements are shifted to lower order position. So that is what we have to write an algorithm. Let me write an algorithm. If you want, we'll repeat this with examples. So as usual, let me write step 1, start. So algorithm. So now I want to delete means delete some element. Let us take this example also. I want to delete something like 4. So at position 2, we have an element 4, we have to delete. So what we have to do means delete first. So item will be copy from array A of P. At position we had element 4. So item is nothing. Now it copies, this 4 has been copied. So vacant space is created. So from that position, remaining elements are shifted to lower order. Therefore, here I use increment loop. So start with for I equals P is already vacant, don't consider P. So start I equals P plus 1, that is from next position to P plus 1 to N. Do the following till the last element. Starting from P plus 1 to the last element, we repeat these steps. Here now we do not consider it. You can take if you want N minus 1. If you consider equal, N minus 1, or if you less than means it's N is enough. But we are considering equal in algorithm. Let me take N minus 1. Starting from P plus 1 to N minus 1. So now follow. What is P plus 1 in this case? So it is what we are trying to do means A of P plus 1 means we have an element A of I will be copied to, you can take here A of I minus 1, that is P plus 1 means, P means 2, P plus 1 means now I is 3. At 3 we have an element, so that is how you can do. You can write many methods, different methods. You can now, so A of I will be copied to its lower order position, I minus 1. So we have a 3, so this will be 2, it is copied. So what is at 3, we have 5, that is copied here. So this is copied. So this becomes vacant. Then what happens? I plus plus. So it was 3, I was 3 now. Now I becomes 4. So 4 is less than 5. So number or 4 is 4. This number of elements what we had 1, 2, 3, 4, 5. So 4. Now I is also 4. 4 is less than 4, false. 4 equal to 4. Again repeat. Now 4 minus 1 is 3. What is at A of 4? We have element 6. that will be copied to here. And then I plus plus 5. 5 is less than or equal to 4 is false, we quit. So next what happens? For n, that is indirectly, we repeat this, we'll take an example once again. And then after this, reduce, the number of element is reduced by 1, then stop algorithm. You can use different method also. You can start with p and then you can write I plus 1 to I or I minus 1. This you can use in different techniques. Only thing is, some algorithms bear different way of doing this. So if you make p here, so that plus 1 you have to write here. I plus 1 is vacant, there you copy I of I. That also do, or you can do this one also. Whichever is comfortable, you can use it. So let me take now with the example. If you want to do p is also no problem. Right, this is p, then you make this I plus 1. So both our method we learn, no problem, this simple one you can understood. Because we are taking lower order, I want to in I minus 1. Higher order means plus 1, that's why I retain this technique. It's quite interesting. The explanation also same, and the mathematically it's also decreasing, minus, lower order. That's a higher order, plus 1. Like that also you can think, that's why I took this method, or another method is also you can perform. So now let us take an example, we'll fill with some numbers and we'll carry out this, how it works. 4, 5, 6, some 7. So how many number of elements are there? You can see. Now the number of elements is 1, 2, 3, 4, 5, 6. So n number of elements in an array is 6 right now. The algorithm works with the array consisting of 6 elements. And let me take the same position where you want to delete the number at p, that is p equals 2. So at a of 2 we have element 4. 4 has to be removed. So follow the remove first. Deletion is to remove first. So after remove, copy it to item. So item becomes 4. Now the remaining elements after that, from that position, next element, all elements are shifted to lower order. So now you can see 5 at 3, 6 at 4, 7 at 5. So all will be reduced, lower order. We'll follow now. So I, p plus 1. What is p? We have seen. So now I become p plus 1. 2 plus 1 is 3. So now I is 3. So what is n number of elements? We have to check here number of elements, as already I have told. 1, 2, 3, 4, 5, 6. So n is 6. 6 minus 1 is 5. You can see here also written 6. So 6 minus 1 is 5. So now I is 3. 3 and 5 compare. 3 is less than 5? Yes. Repeat. What you are trying to repeat? A of I. What is A of I? 3. I is 3. We have element 5. That is copied to A of I minus 1. So 3 means 3 minus 1 is 2. So A of 2 means nothing. A of 3 we have 5. That 5 is shifted. This is how we shuffle. We shift the elements from higher order position to lower order. Not swapping, not swapping, just we are moving. This is mathematically how we do. So next, I plus plus, only one statement for loop. So I becomes 4 increment loop plus 2. So now what happens? 4 is less than 5, repeat again. So now A of 4, we have element 6 and A of 3, that is a minus 1. So 3 vacant space, there we copy A of 4. What is A of 4? 6 will be copied. 6 is placed at A of 3 and this becomes vacant. Then I plus plus, I becomes 5. 5 is less than 5? False. 5 equal to 5? Yes, true. Repeat again. So what you are repeating? A of 5. So A of 5, we have element 7. So that will be copied to A of 4. So A of 4 is nothing. So A of 5 we have element. So there it is copied. So stop. Now this loop mathematically stops. So I plus plus 6. 6 is less than or equal to 5? False. That is, we reach the last element mathematically, where we can see there are no more elements. This loop will decide mathematically there are no more elements. Stop. Then n equals n minus 1. N previously 6, now it becomes 5 because the number of element present after deletion is 1, 2, 3, 4, 5. So n is, there exist 5 elements. So this is the algorithm for deletion. So we can copy this algorithm. This also they'll ask for they'll be asking in the exams for 3 marks, sometimes 2 marks algorithm with example 5 marks. Sometimes both insertion and deletion will ask for 5 marks. I think you have understood. We'll write a program. So simple things. So we can have a system at home, we can practice these programs also. Or you'll come to the labs next, when you get all these problems or over, so then you can come and execute this program. But theoretically you learn these things, very important things. So let me write programs. Let me write the program. It's exactly similar what we could have written like this only. No problem, we'll write. You also practice like how I write, there is nothing. I'll start complete the entire program. You also take pen and start writing like this. After learning, after listening. Okay, video can be paused and start writing yourself. When you got doubts and again see the video, what's the problem, and then you continue. So again, as usual, top-down approach, 3 input output processing method. So what you require? So deleting an element means as usual same, you need an array. From where you delete? From an array. So an integer a of 10. What other things? So we need subscript I, we need number of elements, we need position and item to copy. Exactly same number of variables, same statements, but here also this repeats the same thing. See out. So enter n, the number of elements, size. Enter size of an array you can write, enter number of elements, enter how many elements, all those things you can write. So C in, same thing, so n. If you take that example, so this example, n is equal to 2, 3, 4, 5, we have 5, so n is 5. If you give 5, so vacant space will be there, then you have to add, same thing, previous. Then C out, we have to input elements. So enter elements of array. So enter elements of array. So after this loop, like that all the elements will be stored. Right now till here it's empty. After this for loop, for I is 0, I is less than n, I plus plus. Now use C in, a of 0, a of 1, a of 2, like this, a of plus plus. It repeats and stops till number of elements n. Next, after this, as usual, C out, so enter position, because from where you have to delete means at that position. So here you use C in P, exactly similar. So next, same thing. After this, check that position is valid or not. So we'll write here, if the position you enter is greater than n means same thing, C out, so invalid position. So deletion cannot be performed. Anything you can write. Position, invalid position. Next, else, so it is a valid position, you can delete. How you delete means follow the procedure. First, algorithm says, first step, delete the element. Which element at that given position. Copy that item is equal to A of P. If the position is valid, then we'll remove, that is, if P is 2 means we remove this 5, the item becomes 5 with respect to this example. Then what we do? Repeat this, remaining elements. I equals P plus 1, I is less than n, n minus 1 is not required, less than. I am not considering equal, I plus plus. Each time what we do, we shift the elements, that is A of I minus 1, nothing. So there we copy A of I. Repeated, exactly similar, they are shuffled. And then after this, n minus minus you write. Number of elements are reduced. So after this, we have C out. You cannot also, the deleted element also you can write. You don't know. That message also you can write or just you write. So array elements after deletion also you can write. I wrote just array elements, that obviously one element will be deleted. Same thing, you displaying an array, start from 0, I is less than n, I plus plus. Then we'll write cout set width of 2, 4, you can give as you like so that it looks neater. So that is the end of else statement, end of program. So same thing as I explained algorithm. So this will be shifted here and this will be shifted here and then loop terminates. Then n minus minus, so n becomes 4 and display 4 elements, 2, 3, 6, 7. End of else, end of program. So this is a deletion algorithm. This is how deletion is performed. So I think you can trace with the values, it exactly works in what I did for algorithm, same, only this part I put semicolon and we wrote like this. So algorithm just simple steps, this is a program, complete program. I think you have understood and okay, write this algorithm and program in a separate notebooks, computer science notes you write. I think we'll continue next is the sorting and we'll learn in the next class. Otherwise you may get confused many algorithms at the same time. We'll continue in the next class. But keep writing the assignments. Assignments means notes and also read the textbooks and daily 1 marks, 2 marks and 3 marks questions. Keep writing assignment as usual and write algorithm and the programs.